the distributive property. So let's go back to looking at something familiar with an area model. Write an expression for the area of a rectangle whose width is 9 and whose length is x plus 3. Remember, our formula for area is length times width for a rectangle. So you can think of this as being two rectangles. One has an area of 9 times x, that would be the green rectangle, and the other has an area of 9 times 3. That would be the yellow rectangle. An expression for the total area would be to add them together to find the sum. So 9 times 3 is 27. So that would be 9x plus 27. Or you can think of this as one large rectangle, and you can have the length times width be that 9 times the whole side of x plus 3. So finding the area of the rectangle demonstrates this distributive property, showing that 9 times x plus 3 is the same as 9 times x plus 9 times 3, or 9x plus 27. Remember, 9 times x plus 3 was representing that one large rectangle versus looking at that area of the two smaller rectangles, but both were representing the same amount of area. But what happens is the 9 is distributed to each term of the sum x plus 3. It's multiplied with each of those terms in the sum or inside the parentheses. So now let's try without using an area model. So we have 6 times the quantity of x plus 4 and 5 times the quantity of x plus 7. So we want to use the distributive property to rewrite these expressions. We want to distribute the number on the outside of the parentheses to everything on the inside of the parentheses. And you want to think when we say distribute, that's multiplication. So in the first expression, the first example, we'll have 6 times x plus 6 times 4. And we can simplify that to 6x plus 24. In the second expression or example, we'll have 5 times x plus then 5 times 7. And we can have that simplified to 5x plus 35. So let's check our answers. Again, 6 times the quantity of x plus 4 equals 6x plus 24. And 5 times the quantity of x plus 7 equals 5x plus 35. Here are 2 more to try now where we have subtraction inside the parentheses. But just think that's adding a negative number. So when we're distributing, we're still going to take that number on the outside and multiply it to everything on the inside. So for the first example, we're multiplying 2 to everything on the inside, to the x minus 1. So first we'll have 2 times x plus 2 times negative 1. And that can simplify to 2x plus negative 2, or just minus 2. In the second example, we're distributing 4 to the x minus 8, so we'll multiply 4 times x plus 4 times 8, or 4 times negative 8 rather, because it's a minus 8. So that we can simplify to 4x plus negative 32, or just 4x minus 32. Let's check our answers. Again, showing 2 times the quantity of x minus 1 is the same as 2x minus 2. And 4 times the quantity of x minus 8 is the same as 4x minus 32. So now we can generalize and thinking of any number on the outside of parentheses, so we're thinking of that as our variable a, times anything inside parentheses, so we're using the variables b and c, we're going to multiply everything on the outside times everything on the inside. And it doesn't matter where that variable is, whether it's on the outside in the front, outside in the back, whether it's addition inside the parentheses or subtraction inside the parentheses, you're always just finding those products. So first we have a times the quantity of b plus c equals a times b plus a times c. So our example, we had 2 times the quantity of x plus 3. So that was 2 times x is 2x, and 2 times 3 is 6. So that gave us 2x plus 6. That's very straightforward distributive property. You have your number in the front and you have addition in the parentheses. But then you could have your number after. You could have parentheses b plus c times a equals ba plus ca. So our example here, we have x plus 7 times that quantity times 3, but we're still doing that outside number. 3 times x is 3x, and 3 times 7 is 21. So 3x plus 21 is what that equals. So that just has that first number on the outside of the parentheses at the end instead of the beginning. Then we can have subtraction on the inside of the parentheses, which works the same way. We have a times the quantity of b minus c equals a times b minus a times c. So 5 times x minus 2 is our example. So 5 times x is 5x, and 5 times negative 2 is negative 10. So that would be 5x minus 10. And finally, if we have subtraction inside the parentheses and we have a variable after the parentheses, it still works the same way. We have the parentheses b minus c times a equals ba times ca, where our example is the quantity of x minus 3 times 6. We're still going to do 6 times x is 6x, and 6 times negative 3 is negative 18, so 6x minus 18. So the distributive property is also used to eliminate parentheses so that we then can combine like terms. This is when it's most helpful when evaluating expressions. For example, here we have 3 times the quantity of 4x minus 6. So here we're distributing the 3 to the 4x, so that would be 3 times 4x, which is then 12x. And then we're distributing the 3 to the negative 6, so that would be 3 times 6 is 18, so that would be minus 18. So we can have 12x minus 18. So we can then combine that expression with anything else with the same like terms as either 12x or negative 18, but we can do that now since we got rid of the parentheses. So that will be very helpful in the future when you're evaluating expressions.